Welcome back to the second lesson in this series on learning Python for beginners. In this lesson, you'll learn how to store values as variables. In this lesson, we'll look back briefly at the work we did last lesson on expressions and values. We'll explore the additional arithmetic operators that I challenged you to find out about at the end of last lesson. And we'll learn how to assign values to variables and use variables in expressions, and the lesson will conclude with some tasks for you to do. So to recap, last lesson we used the Python shell to explore the relationship between expressions and values, and we saw that there were two broad categories of expression: numerical expressions, which the computer evaluates in terms of their number value, and string expressions, which are enclosed in quote marks, and the computer evaluates them in their literal sense. So we can see here in the image, the numerical expressions 3.5 is evaluated by the computer as the value 8, whereas the string 3 plus 5 is evaluated as a string of 3 characters. It's worth noting here that because I'm using my expressions to make pictures on the screen, I'm putting spaces in. So you can see there's quite a big space, and there could be more than one space between the 3, the plus and the 5. The computer will simply ignore those spaces, so you don't have to include them. You can if you want. I'm including them to just make the screenshots a little bit easier to read. So last time I asked you to explore 3 additional operators: the double star, the double division sign and the percent sign. There's a couple of things I want to talk about here. First is, if I say explore something, it might be helpful for me to tell you what I'm imagining that you will do, what I'm suggesting that you will do. And what I would do if I was asked to explore what something meant would be to try it out. So I might try 2 star star 3 or 10 double division sign 3 and see what results I get. Keep doing it until I start to get an idea, try out different values until I start to get an idea of what that operator does. Anyway, you could stop if you haven't done that yet, you could stop the video now, go to the Python shell and do a little bit of exploring like I've just suggested, because on the next screen, which is going to come up in a second or two, I'm going to give you the answers. So if you want to try and find it out for yourself, this would be a great time. So these are the 3 additional operators that I asked you to explore and their meaning, and I'm going to go through this with you. So a double star, double asterisk, means to the power of. Double forward slash, double division sign, means integer division, and the percent sign doesn't do percents at all. It gives you the remainder from a division operation. So let's have a look at each one of those in detail. So a double asterisk, a double multiplication sign, raises one number to the power of another. So 5 star star 2 is the same as saying 5 squared, 5 to the power 2. And if you remember what that means 5 times 5. So 5 star star 2 is the same as 5 times 5, and you can see the answer there, 25. So what's 2 star star 4? If you've got a bit of paper, write it down so you can check that you've got it right. And the answer is 2 to the power 4. That is 2 times 2 times 2 times 2, or 16. Now you know what the double star means. You could pause this video, go to the Python shell and just try a couple of them. one thing I sometimes challenge my students to do is to try to make the largest number that they can without making Python crash. But it's just something to play about with. A double division sign carries out integer division. What that means is that the first number is divided by the second, but the computer only records the integer part of the answer, integer being a whole number. So here's an example on the screen. 16 divided by 5 is 3.2, but 16 integer division by 5 is 3. We just lose everything after the decimal point. Sometimes you need to have an integer result from a division and you just lose the extra. It's like rounding down to the nearest whole number. The percent sign works out the remainder, and it's a good complement to integer division because it tells you what's left over. Most young learners learn about remainders when they're quite young, perhaps when you're at primary school. So for example, 10 divided by 3 is 3, remainder 1. 16 divided by 5 is 3, remainder 1. So 16 integer division 5 is 3, and 16 remainder 5 is 1. So it's you divide the first number by the second, and then you just take the remainder. It's also called modulo or mod in computer science, and it's used quite a lot in other activities later on. But for now, if you want to have a little explore of this, both integer division and remainder, so you can pause the video, go to the Python shell and just try a couple of these until you're comfortable that you understand what these operators are for. We will use them again in the future. This concludes the part of the lesson where we look back at what you've done before. Now let's go on to a new topic, which is how the computer can store the values that it finds. So just to remind you, when you type an expression in the Python shell, the computer will immediately evaluate the expression, that is, find its value, and output the result. It will show you the value on the screen. But quite often, we don't just want to do that. We want to save that value to use again later. The way that the computer does this is it stores the result in its electronic memory. In the earliest computers, you would simply give the computer the electronic address where you wanted to store the value. Every location in the computer's memory has its own number address. So you would just tell the computer what number address to use to store the value. That's not very convenient. It means you have to use very large numbers because there are millions or billions of locations available. So we don't do that. Instead, we give an area of electronic memory a name. We can choose almost any name that we want, and then we assign a value to this variable. Perhaps it's easier to see an example. So here are 3 examples. So I've created an area of electronic memory that I've called X, and I've given it the value 23. So the value 23 is stored in an area of memory, and the computer will give that area of memory the name X. The next one, I've asked the computer to evaluate the expression 19 plus 30 and to store the value in an area of memory called Y. And in the final example, I've given the string hello and stored it in the electronic location with the name Z. They don't have to be single letters. I've just done this to make it very quick for us to see an example. So I've created 3 areas of electronic memory, given them labels X, Y, and Z, and stored different values in each one of those 3 locations. If you're wondering how long that data will stay in that location, it will be for as long as you've got Python open. If you close the shell or close Python, then those memory locations will go back to being empty. But as long as you've got the shell open, you might have it open for an hour, and an hour later that data would still be stored in those locations. Remember this structure. We always give the name of the variable, then an equals sign, then the value that we want to put into the variable. It's never the other way around. So just get that in carefully into memory. Variable equals value. We're going to look at loads and loads of examples of that structure over the next few lessons. In Python, there are some rules about the names we can give variables. I just gave those three variables the name X, Y, and Z. They're not very good names because they don't help us to remember what's stored in that variable. So it's important to give variables helpful names that remind us what values we're storing in there. And there's some other rules. These apply to Python and quite a lot of other programming languages. You can see the rules on the screen here. The name of a variable must be a single word. It must start with a letter, though it can include numbers and the underlying character, but no other characters or symbols. You can use upper or lowercase letters. My X, Y, and Z were lowercase, but the computer will remember which you used. So if you use X, lowercase x one time, then you have to continue to use lowercase x to refer to that variable, or the computer won't realize you're talking about the same variable. Well, what am I saying? I'm talking about using variables in expressions. How do we even do that? Well, if we type the name of a variable, that is an expression, and the computer will evaluate that expression. So if I type X, the computer will recognize that X is the name of a variable, go to the memory location X and show me what is in there, and similarly Y. Can you see why the computer will evaluate X and Y as variable names and not as strings? That's not the string X and the string Y. They're variables X and Y. Can you see why? It's because they're not in quote marks. If they were in quote marks, the computer would take that as the string, the literal letter X. But because it's not in quote marks, the computer knows that I'm using X as a variable name, and it goes to the previously named location X, finds what's in there, gets it out, and shows it to me on the screen. I can also combine variables in other ways. So, for example, I could say X plus Y. That's an expression using an arithmetic operator. So the computer will go to location X, go to location Y, get those two values and add them together. And here's another example. Z was a string, storing the string hello. So if I add that to the word again, it will say hello again. Here's an interesting thing that happens. Here I've given the expression X plus Z, and that has confused the computer a lot because X stores an integer, a numerical value, and Z stores a string, the word hello. And the computer can't cope with that. It can't use plus to join an integer and a string. Plus does a different thing with integers and strings. With integers, it adds them numerically, and with strings, it joins them together. So we can't use plus to join an integer and a string. And Python's quite good. It will tell us. If we try to do something impossible, it will tell us where it's found the error. Line 1 I just typed this in the shell, and unsupported operand. That means it's the operator doesn't work between an integer and a string. I'm going to talk a lot more about errors and error messages over the next 2 or 3 lessons. Error messages are really our friends. They will really help us to improve our programming. So this is the final slide in the lesson, and as usual I'm giving you some work to do. I'm suggesting that we set up those 3 values x, y and z. So practice assigning values to the variables and then using variables in expressions. Remember what I said earlier about how to explore. Just try different values, try doing different things, see what happens. And I've got a couple of challenges for you. What's the largest number you can create from those variables? And what's the smallest decimal? The smallest decimal fraction that you can create using those values. You can use them more than once, and you can use any of the operators that we've learned. Good. Okay, so in the next lesson, it may increase the power of your programming by showing you how to get input from the user and use the input in your expressions. So see you next lesson. Bye for now.